Doing this is we're concerned about the rate of change of the area of a circle. Okay? We're concerned about the rate of change of the area of a circle, so we're going to say A equals pi r squared. Now, the one thing that is consistent here is the fact that the rate is changing with respect to time. That's the one thing that's consistent. The radius is changing at a constant rate with respect to time. It says here it's 1 foot per second. And the area is also going to be changing in terms of seconds. But it'll be changing at a different rate. And you can think about this also as this is, this is a one-dimensional change where this is a two-dimensional change. Now, dA dt, well, let me preface that by saying, even some one-dimensional things, like we saw the ladder falling, the one-dimensional changes don't always change at the same rate. So we're going to say the rate of change of the area, dA per time, remember the derivative, or the variable that we're taking the derivative with respect to is in the denominator. Up till now it's been dx, but now we're using time as our variable. Now, what is the derivative of pi r squared?
2 pi r.
It's going to be 2 pi r, but it's going to be dr dt. Because again, radius and time, and area and time, we're talking about different variables. In fact, this variable of time that we're taking the derivative with respect to isn't even in the equation, and it won't be in the equation when we're doing these related rate problems.
So there's a t at the bottom?
That is a t, sorry. Now we can start plugging in specifics. So what's happening in this problem? What do we know? Do we know anything about the area? Or the rate of change of the area? From what the problem says.
R is dr dt equals 1.
Alright, yeah, r dr dt right here is 1. Alright? Now, remember we said the area is changing based on the radius, but at a different rate. So it's going to depend on what the radius is. If the radius is changing at a consistent rate, then as the circle gets bigger, the radius is going to change even more. Or quicker, I should say. So what radius are we concerned with here? 4. So I have the famous wrapper, 2 pi, times 4. That's for all the people who will be watching this viral video. dA dt. And we wind up getting that dA dt is 8 pi, and we want to include units with it. Since it's area, and we're talking about feet, it would be square feet per second. Go ahead and stop it.